Alright, I want to go over a few things. The first thing is the layout that concerns the relationship between the profile and its location in the bottom of the plane laterally. I have an old plane here. This is about 160 or 70 years old. I don't really know. But what I can show right here, if anyone can see this, is that the profile, the wedge pocket is slightly to the side of the profile. So that means that a portion of this blade is to the side of the profile. There's a portion of the blade that's not actually working, but it exists past the profile itself. There's a reason for that. You cannot have the blade terminate precisely. If I use this steel straight edge as a way to illustrate it, you cannot have the profile and the blade end right at that point. It actually has to be slightly past it. And the reason why is so that you have 100% cutting action. The idea when you operate the molding plane, each pass of the molding plane creates a place for the next pass to set slightly lower and make another pass. So if you don't have that crossover between the profile and the blade, you won't get 100% cut. There'll actually be a small little ridge right where those 2 points meet, and you'll never be able to remove that with the plane. So the plane will never be able to advance for the next cut. It'll just create like a block. There's no portion of the blade that cuts that small little spot. So they have to cross over. So that's how you locate, and that's based on the location of the wedge. So in my case, I have some 3/8 scrap steel, and that's what the space that I used to lay out the bottom of my plane. So I'm in a safe zone here, and then I have my blank, and then what you have to do is basically stack them together and align everything with the side of the plane, and then you'll see that I have enough blade right here on this edge to cut through the entire profile on the other side. Now I just barely make it. I should have probably moved this profile slightly to that side so that I'm safely within the entire 1-inch blade thickness that I chose. I could have went to a wider blade. I chose not to, and I really don't like that it's this close, but it should work. One of the reasons why this happened was because I'm doing a lot of this by hand, and even though I laid it out, I can't develop the kind of precision that I need in order to make all that happen. But it's something that everyone should be aware of when they're laying out the bottom of the plane. It's really not a big deal, and it's pretty self-explanatory. What I also did was I used the scrap steel to lay out the top of the plane. So I have the 3/8 scrap steel gives me the side of the wedge pocket, and then the second piece of scrap steel registered off the same side gives me the other side of the wedge pocket. So rather than use marking gauges and combination squares and stuff like that, I just choose to use the same 2 pieces of scrap steel to do all that. The other thing I did was I laid out the first plane, and then I stacked all the planes up I believe they were this way when I did it, and I stacked them up end to end, and then I took a square and I took all my layout lines and came down that way. That way, instead of doing layout in pencil, I just chose to make one pencil layout in the first plane and then copied the layout on all the other ones with the square. And then I used my my jig to lay out the bed line for the blade. And what I did was I took this plane, I took the dimensions of this plane, I went on the internet and I got a percent calculator. There's a website with a percent calculator. I took the total width, then I took the dimension from the back to the bottom of the ramp, came up with a percentage number. Then I took the total length of my new planes, installed that same percentage number into the new length, and came up with a second dimension, which gives me my measurement from the back of my plane to the lowest point on my blade ramp. So it's in the same exact proportion as this antique plane, and it looks fine. It should operate fine. It's not going to be a big deal. And what I also chose to do, because my profile is slightly behind this point, so I know that this wedge pocket is going to open up as I come back into the profile. What I did was I used the 3/16 blade. That's this short little line right there, and the mortise line. Let's see if I can show this. The mortise line for the wedge pocket comes down right to the 3/16 mark, but behind here, up in this profile, it should be open enough to give me my clearance in front of the blade for the chip. If it's not, I can widen it later, but there's no reason for me to go any wider than this down here right now. And I'm getting ready to cut the blanks for the blades out of the 01 tool steel stock that I have. So I have two blades laid out. Let's see if I zoom in on this. This is the cutting face of one of the blades, and then right here is where the wedge would be as it passes through the body of the plane, and then nested right around it is another blade facing the other direction. So I have to cut this and then plunge through here with a hand grinder, and be careful not to cross any of the cuts, and then there'll be a lot of hand work with the files, the bench grinder, and stuff like that. But this is what it looks like. It's laid out in tape, and I'll take it outside, and I'm going to make 4 blades. So I need to do all that. I like to have all this done so that when I come to the next step, I can use the blade to start fitting the wedge and do all the proper mortising for the body of the plane. So I have these blanks roughed out, and what I'm going to do now is snap them away from each other. These cuts don't really overlap completely, but it's better I stay away so I don't create a little nick right in the corner. So what I'll go ahead and do now is try and separate these. There you go. So the rest of this will be dressed up with files and grinding stones and possibly the bench grinder. This is because there's a small piece of scrap that was in between both blades, so this one's much heavier than 3/8. That one was cut to 3/8, and this one has the scrap still attached to it. I'm not going to grind that off with the hand grinder. I'll do that with the bench grinder. And then I'll use the micrometer to set everything to 3/8 of an inch. That's where the wedge goes. Now this was nested in the blank a little bit differently. This is like what I would call a blind cut. So I went ahead and laid out the back of it, and I plunged the grinder in from both sides. So this one just started to peek through. I'm going to see if I can, what I'm going to do is I'm going to clamp this down, clamp it back here, do it with the big clamp. And I'll see if I can roll this one down and just snap it off. There you go. That's it. Now this has to be trimmed to size again, so what I'll do is I'll just set this up and I'll cut this with the hacksaw. That's a straight cut. There's no need to grind that. I'm just bothering my neighbors, roll the racket and everything. So now this one is free, so even though this one, the two blind cuts didn't pass each other, now there's nothing in the way and I can come down and just trim this with the hacksaw. So that's how I get the blades out of the raw stock, and the rest of it's just work with the bench grinder and hacksaws and stuff like that, and pretty easy. I don't know any other way of doing it, so there you go. I have the 4 planes, and I completed all the mortising for the mortise pockets using the jigs. I made my setup with my block, and I cut all this with the bandsaw and opened it up with my chisels, and I fitted all the blades. So everything is all, basically it's a blank blade, but it's all been trued up with files and water stones and set with the micrometer. So this is all very nice, and the idea is that when your plane is at this point where everything is opened up, you need a blade, because the blade is going to help you do the final tuning of all the pockets and all these lines in here to make sure that when the wedge compresses it, that there's no high spots and that the blade doesn't rock, and that especially back along the mouth, that it sits tight against the bed and it doesn't chatter, because that's going to give you a really smooth cut when you operate the plane. So right in here it has to fit very tightly. Now the reason I'm mentioning all this is because at this point, when you have the mortise roughed out and the blade roughed out and inside the plane, you're going to let this sit until you're ready to do the work with the wedge, because then you're going to make the wedge the deciding factor on how the blade fits. So let me try and illustrate that with one of them that I have here. So the wedge is now going to make the blade sit up against the bed. So if I have a perfectly straight edge on my wedge back here, that's my proof that, let's see, that's my proof that this blade is being pushed against the bed properly by the straightness of the back line of this wedge. So if I create the straight line with the wedge and I can't push this blade back against the bed, it means there's a high spot in there. So that's where this one is at that point. So that's where you're going to start using the wedge to do the final trimming on the bed. And the same thing, because the other face of the wedge, this face along the back part of the mortise pocket, that's also going to be a straight line. So when you create that line, you're going to find all the high spots along this, and you'll have to trim those. Once this line and this line are perfectly straight, then you tune the wedge, and you're going to tune the wedge by gradually tapering it. And just for fairness purposes, I'm going to show this wedge, this jig right here. Let me see if I could zoom out on it. This is the jig where you would do the final tuning on your wedge. So for instance, if the wedge was tight at the top and loose at the bottom, I would want to reduce more at the top so I get a closer fit all along this edge. So I would taper. I would take a few shots along the top, gradually work my way back, and then take continuous shots and tune it to create the taper I need, which will go back into the plane and hopefully tune it and make it closer. So the way I work is I have everything set up so I can do all that at once. And I also have, I'll show the other jig. That's this one right here. Let me zoom in a little bit on that. And what I did was I found a way by putting this large dowel in here, so any wedge will just create some friction in here to hold it. And then what I do is I create a straight face. I'll pick one face, flatten it, square up and straighten my one long edge, and then make sure that that edge is square, because I'm working with everything that's square inside the body of the plane. So this edge right here has to be square, so tune that up. Then I use my micrometer, and I already know more or less the thickness of the blade. You could use the micrometer to measure the thickness of the blade that goes through the wedge pocket. Now you're going to fabricate the wedge. So let me just turn this a little bit. So now you're going to use the micrometer to set the thickness of the wedge, and then do your final fitting into the pocket of the plane. And once you can get the wedge into the pocket of the plane, then the last thing you're going to tune is the angled portion, the edge of the wedge that crosses the grain lines. That's going to be the last thing you do. And with the jig, you're going to taper it and tune it so that it goes and creates the bearing that you need to hold the blade firmly in place. And once you get that, once the tip of your wedge starts to get real close to bearing up against the blade, that's the working face of the blade, is right near the tip of the wedge, then I would recommend that you shorten it, because at that point the wedge is almost going to pass through the bottom of the plane. So at that point you're going to shorten it and create an angle, and that's going to be your that's the angle that's going to direct the chip to curl away from the escapement and away from the plane. So you have to create a little angle on that. Let me see if I could just illustrate that with this one. Well, I won't do that. It's pretty self-explanatory. So the other thing I did with these planes, originally I wanted to keep the body of the plane solid, and then I thought about it, and it wouldn't be proper to do that. So what I did was I basically left this dimension here is 1 1/8 inches, so I came down 1 1/8 inches, and then just took everything out and created a large rabbet. And it seems to be working out okay. So you need your blades, you need your plane bodies, you need your rough material for your wedges. You need at least 2 jigs. You need one to hold the wedge, one to taper the wedge. And what I plan on doing is this is my first plane that gives me, let's see if I just come out with this a little bit. This is my first plane that's at this condition where the wedge is rough fitted, and I have the blade sitting on the ramp the way I want. So I'm going to get all 4 of the planes I'm working on at this stage. And the other thing that I can do once I have all 4 planes, let's see, I wanted to show everybody what I'm going to do, because I'm not going to come back and film this, is what I did was I took a template. This is a piece of light cardboard, and I took a template, and this is the top of the wedge. But what I noticed on the other set of planes that I made, the 8 planes that I made, is I copied the entire wedge. And what happens is, because these angles change minutely inside the body of every plane, it also affects the length of the wedge. So after my planes were completed, if you compare each plane, each wedge is a slightly different length. They jump up and down when you look at the full set of planes. So what I want to do is avoid that. I want to make it look a little more professional. So this angle right here represents the body of the plane. And what I want to do is I basically want to just push this plane, this template up against the body of the plane, and then trace the template, so that by doing it this way I create 4 planes that are all the same length. The wedges are all the same length from here up. What's ever inside the body, I don't care, but theoretically that should all be the same. Otherwise you're going to create wedges with a slightly different length. And also, if you go and make other planes, you can just use this the same way. This is good forever as long as you keep it in decent shape. You just trace it, and this is my universal template for the body of the wedge. I still have yet to do the router setup. I'll probably do that right at the end, but what I'm going to go ahead and do is put this on the router and create the radius in the back. This is the radius that softens the plane so that you can push against it as you're working. And then I'll take, I think I have a 3/16 radius bit, and I'll go ahead and just round over the top of this. It won't be anything fancy. And probably some final sanding, doll it up, take some of the dents out and stuff like that. And I should be close to being done. There's going to be some sanding, of course. Now the next major step after all that, and I won't proceed until I have all 4 planes ready, is that I have to start working on the shape of the irons. So you really can't do anything with the irons as far as shaping the profile until after you have it where the wedge is set and everything is tuned. The reason why is because you have to keep installing this blade as you're fitting and shaping the profile. You have to be able to keep installing this back in exactly the same spot in order to tune the profile. So it doesn't make any sense to do that before you have everything ready to go beforehand. So I'll do all 4 planes, then I'll start tuning the profiles. Once I get those roughly shaped, I'll harden them. Probably not going to show any of that, but it's just a normal process of going through plane making. I've done it a couple of times already. Let's see how this plane works. The key is to hold it at the spring angle and push it firmly against this edge. There's really no need to push it down this way or this way, because it'll fall into the cut as it advances. The key really is just to keep the pressure right up against this edge at the spring angle, and then the plane will advance straight down. What I have found though is that if you don't do that, what'll happen is it'll roll away a little bit, and it'll start cutting in a random spot. And also, if you don't hold the spring angle and it rolls too far over, when you go to cut the step will be too far back. So it's tricky to do freehand, and you could set up a fence. I've done that before, but I want to try and just do this completely by hand. So I have it set for a very shallow cut. I made a couple of passes already. I think I'm going to get the whole thing without adjusting it again. So when I built the plane and I tried it, the last step at the top of the board came out too deep. So I laminated a piece of brass to the part of the plane that defines the step to make the step shallower. And I just spent the last day and a half gluing all this up and filing it. So I already tried this plane, but this will be the first time that I do it with the strip of brass in place. Probably like a little low spot in there. I might have to do some more work with this blade. Okay, I'm just starting to grab on the final step, so I got about probably another good 1/16 of an inch to go straight down. It looks like I'm holding the spring angle pretty well. It's nesting on the profile pretty well with the spring angle the way I want it, so we'll just maybe another 3 or 4 full passes. And in theory, once the step is cut, it should stop. You shouldn't be able to make any more passes with it. It should just it should just stop cutting all by itself. Looks pretty good. The grain lifted a little bit in one spot. Let me get some close-ups of it, but you can see how it looks. It's real nice and smooth. Right through here, there's no chatter. You can hear how it cuts. So the little tiny lifted area, but everything else, this basically has like a well, it's a mirror finish. I would say it's got like a 1500 grit finish. It's basically a mirrored finish, but that's because it has very forgiving grain. So this is the profile right there, and that's the way the plane bites into it. So let's see, there's your vertical spring angle, all done by freehand. I finished the number 6 molding plane. It's all rounded over, broke all the edges. I decorated this area a little bit with one of the hollow planes. I spent quite a bit of time on the blades. I could spend more time on them. Had to add the piece of brass to adjust the step. I got a piece of, I've done a ton of samples on pine. It works fine, except it's, I don't want to be misled because it's a very soft wood. So I have some American chestnut here. It's a very small piece, but it's not pine. So I want to see how it cuts. Then that. It's a little hard to push. It's definitely more difficult to cut than the pine. Okay. The step is just starting to appear. That's it. That's it. It's just a really good finish. Let's see, we turn it this way and we look at it. There's no chatter. There's no flat spots. The curves go one right into the other. The step is very well defined. It's nice and square. It's sharp. It's crisp. There's no chatter in it. The proportions are very nice. I didn't want this area to be too small, so the step is very critical. You can't make it too small so where it's not noticeable, and you can't make it too deep because then this area will shrink. So, and you're looking for flow through here. So this is the way the old timers did it. Back in the 1800s, the 1700s, this was all they had. This is American chestnut. This is an extinct species of wood in North America. This board was milled probably no later than the 1890s, and this tree could have stood possibly in the 1600s. So this is quite old and quite rare. So all four of them are done. They're all smoothed over and sanded. They're a nice addition to my collection. More importantly, I wanted something that I could use. There's no sense in making something that's not practical. So thanks for watching, and good luck if you decide to make a pair of molding planes for yourself. Good luck, and stay with it. It's not easy, it's not super hard, but you'll have something that you can use to make some nice furniture with, and that's what I'm going to be doing in the future. So good luck to everybody, and thank you very much.